Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
Hello, welcome. My name is Chad Gill, and I'm the host of the This is Concrete podcast, where I talk with leaders in facilities management, architecture, contracting, and more. So this episode is brought to you by Concreate. Concreate is a concrete polishing and coatings company with nearly 20 years of experience working in commercial, industrial, and residential markets. So whether you need smooth transitions for your warehouse traffic, a show-stopping lobby floor, or a seamless concrete accent wall, we can provide the skill and imagination that you need to make your concrete uncommon. So what are you waiting for? Visit us at thisisconcrete.com to learn more about Concreate today. So today we're back again for round two with Clif Rawlings. He talked to us earlier about kind of tooling in general, diamond tooling mostly and stuff like that. He's the technical director at the SASE company. He's also pretty instrumental in the CPC and originally the CPAA, and then serves on the CPC board of directors now, and does a tremendous amount of polishing, training, and polishing experience as well. So, Clif, thanks for coming back. Guess today we're going to kind of focus. Today we have video, we have presentation slides. We're going to make the real deal here. And today, I guess we're going to talk about more aggressive tooling, like prep and removal tools. Correct?
That's correct, Chad. Yeah, thanks again for having me on for a second one. Like you said, we spoke in the first podcast about just tooling in general, metal bonds, resins, hybrids, all of it. But you and I decided another topic would be, let's dive a little deeper into the coating removal side of tools, because there's a lot of confusion on that side of it. So we thought, why don't we just go ahead and dig a little deeper into the coating side of it and kind of explain what the tools are used for, maybe some tips and tricks, and just kind of walk through the PowerPoint.
Yeah, I think that makes a lot of sense. I mean, I know my guys ask me, and we always look to figure out, what the right tool for the application is, and sometimes the right tool is the one you've got. But it'd be a whole lot better if you can kind of take a look at a coating or whatever it is you're trying to remove and dial in with shapes and bonds or whatever.
Absolutely.
So yeah, floor's all yours, man. I'm ready to learn.
All right, thanks. Let's jump in. All right. So as we said before, a lot of these inserts are pretty much pulled from our SASE University that we teach every other month. We teach in Knoxville, Tennessee, mostly at our main facility there. Actually, it's in Rockford, but Knoxville area. But we have been teaching some other classes in our Kent, Washington office. We have a Dallas office and a Orange, California office as well. So we're trying to spread out our trainings and our full universities throughout all of our different locations this year, and just kind of go to our website and check it out and see where our training classes are and what times, and just get signed up if you want. But this is kind of an insert from one of those classes. I've added a few things to it to kind of make it more concise, so it's shorter, so it's not so long-winded, hopefully.
Awesome.
All right, coating removal. All right, how to remove the coating off the floor. There's a couple things you got to determine. First, you want to identify what type of coating or glue that you're trying to remove. You want to determine the thickness of the coating of the glue or coating. And then also you want to determine, check and see how well that coating is, say, bonded to the floor. So you can do that with hand scrapers, hand grinders. That kind of helps you determine as to how easy or difficult it may be to remove that type of coating off the floor. Does the coating have sand or broadcast agents for non-skid in it? So if they do broadcast sand in for non-skid, that also can change the way and the method in which you're going to want to remove the tool and the type of tool. Because you want to use basically a harder bond in that scenario, because sand is very aggressive to your tooling. So if you can, pop up the coating, measure if you can. So they do make coating thickness meters to kind of help you with that. Those don't work great, but usually if you can pop it up and kind of see how thick that coating is, it's going to save you a lot of time. When you get into the coating removal type of things, and I'm going to talk about the thicknesses of coatings and which tools, when we get into that, which one you would want to choose. But as far as the technique, when you're using a walk-behind grinder, for example, you're going to increase your overlap. Normally, we say 1/3 overlap in most cases, but when you're getting to coating removal, we'd like to recommend at least half overlap. So half your machine on the coating, the other half off of the coating onto, say, the concrete that you've already removed. That allows your tools to stay sharp and open and continue to cut. There are different types of tools. Go ahead.
You're using the abrasiveness of the concrete to keep tooling from either glazing over, or if you got coating build up on the cutting edge or something, it kind of comes through the concrete and breaks that and cuts through that, or it kind of sheds it.
Absolutely correct. Yep. So yeah, what you're saying, Chad, is if you've got the abrasiveness of the concrete to the side that's already exposed, that is going to clean off any coating or glue that may be stuck to your tooling, and clean it off so that it's sharp edges when it's coming back into the coating material to remove it.
And this is applicable, I mean, for mostly planetary machines. If you had a counter rotating, you would have to do a little bit different. The idea is the same. You need to get to raw concrete to clean is, I guess, the word I'm using, to remove, make sure you have a sharp edge. But because you got a planetary, it's always going the full circle around. So your overlap has half the time cutting and half the time being scraped, I guess.
That's correct. And good point on that. If it's a non-planetary, like you said, it's more stationary type grinder, you would have to just do the typical, they call it the swing motion, to kind of swing it back and forth to kind of get it into that coating and then get it out of the coating. So you're basically kind of dipping in and out so that you can sharpen your tools, get back into the coating, sharpen the tools on the exposed area. Same concept, but just different method, I guess.
Makes sense.
We're going to cover different types of tooling. So sometimes you just have to try different types of tooling to see what's going to be best. You don't really know exactly until you start playing around with it. And also keep a watchful eye on your tooling life, because there are different types of tools. Some are made for softer concrete, harder concrete, if you've got sand in the coating or not. So just definitely be very careful of that, and be very watchful, or mindful, if you will, of the different types of tooling and your tooling life.
When you're telling people to check their tooling, are you saying every 30 minutes, every 500 feet? How do you normally gauge that?
In the very beginning, you need to check it probably every 5 minutes, at least in the very beginning. And I'm talking about, you may not have to pull the machine back or tilt it back. You may just lift the skirt and have a look. But tilting the machine back is the best way to do it, and actually see exactly what you're doing, and see the life that you're actually getting out of the tools. And reading the floor, the amount of dust that's left behind that the dust extractor can't keep up, can also be a very good gauge. If it's just a ton of dust and coating that the vacuum can't keep up with, you may be cutting too aggressive, too fast, and your tooling may be wearing extremely fast. So use that as a gauge as well. If you're cutting wet, obviously same thing. The amount of slurry and the amount of coating that's left over may be an indicator that it's cutting too fast, and so is your tooling. It may be gutting or wearing too quickly as well. So in the beginning, every 5 minutes for probably say 10, 15 minutes at least, check it. Keep checking your tooling, your life, and make sure you're not wearing through tools fast. After you get past that first probably 20, 30 minutes, and you can see that it's not visible or measurable wear, then you're probably okay. You can keep moving, and then you can move back to, when you take a break, check your tools. If you need to go smoke break or whatever it is, if you're doing dry grinding, stop to change your bag, check your tools again. But at that point, you're every 30 minutes to 45 minutes at that point.
Okay.
All right. So metal bonds are kind of the go-to tooling for first step in most scenarios, whether it be you're just going to grind and polish and starting with a new slab, like we talked about in the last podcast. But when it comes to coating removal, metal bonds are a good first step to try, at least, because it's one of the least aggressive tools out there, and less damaging to the substrate, the concrete below the coating, when you're starting with just a metal bond. Now, on this slide here, Chad, can you actually see the pointer being recorded? Okay. So the top tools here, you have a single segment on a trap or trapezoid style base, and then you have a round, which is a 5-seg. These tools are typically used under smaller, lightweight machines, like say your 20-inch and smaller type machines. It's all about, we talked about in the last podcast about down pressure per square inch. Well, in this case, obviously, we're increasing down pressure by having only one segment, versus here we have a double segment tool. Same concept here. We have a 5-segment versus a 10-segment, just reducing half the down pressure, or increasing the down pressure per square inch on your segments. So rule of thumb is these tools here would be typically for a smaller machine, lightweight machines. The heavy machines, like your 30-inch and larger, that weigh say 1,000 pounds, 800 pounds, are going to use these tools. Now, why would I use one versus the other? Well, these trap style with the segments on them, the double and single segments, those are obviously going to be more aggressive. So that's going to be a little bit more effective at removing coatings versus, say, the round style with these beveled edges. That's not to say that the round side can't remove coatings. They can. In fact, they're very effective at, say, just removing a cure and seal on new construction, or just a really thin glue, or even just a thin coating in some cases, especially when used wet. So they can be effective. They're just not as effective as this shape, as you can see here. When you get into the arrow segments, like you see at the very bottom, it's hard to tell. This is sort of a shadow, but this is angled forward. So you have an angle, almost a bevel forward on both of these segments. So these segments are available in different bonds and grits, but the angle and the shape of it has a tendency to want to cut up under a coating, kind of help remove that coating a little more efficiently. So just another option that's a little bit more aggressive than these two up here, but within the same family and leaving the same profile behind as well, which is important.
So you kind of that's a coating where you're hoping you can peel and maybe chip it up or even shred it.
That's correct. In some cases, you'll have some coatings where they're basically maybe they are failing. It's pulling up. It didn't have a very good bond, so that angled arrow can actually cut up under it and peel it up much faster than, say, just trying to grind it from the top down, so to speak.
Gotcha.
And then the last one on this page is a long life segment. This is basically just 3 very large blocks of our hardest bond that we make. And sometimes that's really handy when, say, you're dealing with a coating that has silica sand broadcast in for non-skids, and it'll hold up really well to that scenario. Or if you've got really soft concrete below a coating, then again, that is a good option for it as well. So when a typical metal bond won't do it, PCD or polycrystalline diamond type tools are going to be probably your best option. That's the most aggressive option too. So what I try to do in this slide is try to show you basically what is PCD. It's polycrystalline diamonds, synthetic diamond produced through a sintering process where randomly oriented diamond crystals are bonded to a substratium of tungsten carbide. So if you look closely in this picture, you'll see just that top sliver, if you want to call that a 16th or an 1/8 of an inch, maybe even, that 16th of an inch is basically the PCD. That's the polycrystalline diamond that's grown on top of this cylinder, which is tungsten carbide, okay? So that's how life starts as PCD. They take these PCDs and you can either put them as a whole PCD. In this scenario, you can see right here, where it's a full PCD, or you can put it in, hang on, my slides locked up on me. There we go. They'll take lasers and actually wire cutting or laser cutting, to do it both ways, and they'll cut these PCD in halves or quarters. So when you see in this middle one, this is a quarter round, so that's a quarter PCD, and this is a quarter PCD. And they can also cut them into smaller where they're 1/8 and then turn them up on the sharp edges. So all of these are basically a 1/8 of PCD. Again, there's different variations as to why we do this, depending on the type of concrete we're working on, depending on the type of coating we're moving, and I'll kind of cover that in the next slide when we do those. All right, so the very top here, this is our standard PCD. This is the quarter, as we talked about. This is your go-to PCD. This is the most commonly used. It works on most coatings that are out there. And this is the most common one we sell because of that, because it is so generic and works in most scenarios. The two below it here, this is again the whole full PCD with an arrow, which this arrow basically is kind of like a wear bar to some aspect. It keeps this one tooth, if you will, from digging too aggressive and gives it some ability to kind of flatten it out a little bit. So that's why you have this. And this is basically just a 30-40 grit arrow seg that's brazed along with a full PCD. Now this is going to be your most aggressive. A full PCD like that is going to be the most aggressive. This is sort of medium aggressiveness, and then this is your less aggressive than the other two. So most aggressive.
Are the arrows on the upper ones do anything for you, or are they just, it's just a shape?
That's just a shape. It's those arrows up there. There's no diamonds inside that at all. It's just a binder to put it into, and we put it into a diamond shape because sometimes you get in some coatings that are thicker than the height of that PCD, and that just kind of helps cut through it a little bit, just to have that arrow in front of it. But the real cutting is going to be the PCD. That's what's really doing the action. Okay. And then you get to the less aggressive. This is, remember, the 1/8 cut PCDs spread out, and then we have a wear bar in the middle to again keep them from cutting too aggressive. So what's nice about this one is if you've got a thinner to medium coating, you can still cut it off very efficiently, but without hurting your substrate below too aggressively by having this wear bar on it. And you can follow this up typically with, say, a 40 grit metal bond. Whereas these other two, especially this one, it's going to take at least a 25 grit metal bond to remove the deep gouges that these leave behind. So these are this is your really thick metal. This is, you're talking about your elastomeric membranes, like your parking depth membranes. When you have your 30 mils or thick epoxies, that's when you're going to go to the full PCD. Anything below that, you're going to look at the medium one. I'm going to go into thinner mill systems like 10 mils or less. So this is when you want to look at this guy here. So we do have, this is called a crushed PCD. So what you're looking at is basically a binder holding the PCDs that are basically crushed into small little grit, if you will. Think of this as a 6 grit equivalent, or maybe a little more aggressive, but PCDs as the diamonds itself, but it's going to last longer. So wherever you'd use a 6 grit to remove a coating or just give you surface prep for that matter, maybe no coatings involved, you just want a good surface prep, this is a good alternative. The PCD crushed PCD. Some people call it split PCD, some call it a crushed PCD, but that concept is going to give you a really good profile for applying a new coating back onto it for a good tenacious bond, but it gives you much longer life than a standard 6 grit can do. And then lastly, these plates are basically everything we've covered so far. All of these tools are available. All the different whole, half, and eighth are available in a plate design. And the reason I would recommend a plate over just our quick change like these is if you've got a really uneven surface. If let's say that it's just a beat up concrete and the machine's hopping around, the plate style is much better because it comes with the bolts and you can bolt it right to your head and you won't throw tooling or plates off when your machine's bouncing around. So it's a good idea for really rough and just beat up jobs.
Yeah, no, I'd certainly run into that.
Yeah, for sure. And the plates are more expensive, so we don't typically recommend those right off the shoot. We typically want to go to something like this. It's kind of middle of the road pricing and just covers most bases. But we always recommend talk to your SASE or whoever sales rep that you deal with, and they can typically direct you into the right tools that you need. I do need to point out that all of these PCD type tools are directional. So you notice I kind of put an arrow up here, just kind of grab your attention. You'll notice that each tool is stamped with an arrow. The direction that tool is supposed to spin, all of them have it, and except for the split PCD, they're non-directional, but everything else is directional. I put a note here at the bottom that A direction, we call it in our inventory, we call it A direction, which is clockwise, and B direction, which is counterclockwise. And all SASE propane grinders, just as a note, are B direction. Okay, they can only go counterclockwise, so you never have to really check your direction of your head on a propane grinder if you're tilting a SASE propane grinder. When you're dealing with an electric grinder, you have to check your direction because you have a forward reverse. So make sure you're going the right direction. And don't trust that the machine says forward reverse. If you've ever had your machine serviced, and if they've ever unplugged the inverter from the actual electric motor, and they don't get the 3 hot leads back exactly where they were before, they can change the polarity on it for you unintentionally. Inverters can take care of polarity with power coming in, but they don't know if you've changed the polarity going out to that electric motor. So I always say double check your direction just to be safe, because you never know if someone did service that machine and didn't get the polarity correct on the back side of the inverter.
And they definitely don't work as well going the wrong direction. We
Yeah.
do run into that. That's the classic. Hey, one side's cutting great, Chad, but the other side just isn't cutting at all.
There you go. Yeah, and they're expensive tools. Yeah, and you'll mess them up. I've seen them get pulled out of their binder when they're spun the wrong direction. So it's really important too, because it is a very expensive tool to mess up.
Oh yeah.
All right. So when dealing with glue, how do I keep the glue from binding up on my diamond tooling? Evaluate the thickness of the glue and the tackiness of it. We have a tool which I'm going to cover next called mastic slashers, which are great for thick and tacky glues. But putting down, we used to always recommend putting down sand as a great way to kind of, it's the whole concept or analogy of flour to dough. So you put flour on your hands or on your working surface when you're going to say make a pizza or dough or mess with dough, right? So it doesn't stick to your hands or the countertop. Same concept applies with sand. Because of OSHA's silica dust ruling a few years back, we've had to change that because you're creating airborne dust by putting, just say, play sand from Home Depot or whatever down. Now we say put it into a 5-gallon bucket, mix a little bit of water into it so it makes it damp sand, not wet but damp. And now it keeps it from being airborne. It still balls up and sticks to the glue and doesn't stick to your tooling, and you don't have the airborne issue as well. So it works really well using damp sand, with whether it be just a metal bond, PCDs, or these new mastic slashers we're going to cover. The damp sand helps a ton when you're dealing with really sticky glues.
And there isn't enough water in the damp sand to create a problem for your vacuums if you're still running dry.
That's correct. That's why I really want to emphasize damp, not wet sand, because and also it gives the sand a little bit of weight. Previously, what we used to have to do when we used just sand, dry sand, we had to pull or slide the skirts up so that the dust extractor wouldn't suck all of your sand up before you had got the benefits of it getting mixed into the actual glue. So when we did that, it created even more of an airborne dust issue. So now we can actually leave skirts down. The damp sand is heavier and doesn't get sucked up as fast into the vacuums and gets mixed into the glue easier that way. So it really was a win-win.
When you're talking about these, as you're coming through there, you're operating variable speed, whether you're propane or electric, variable speed grinders. Where are you setting your speeds? Are you trying to cut with a real slow drag so that you're cutting and not just sliding over, or what? How are you setting your speeds? I mean, you can vary weight and speed as well as the tool.
Absolutely, yeah, good questions. Typically, I always tell people to just, if you have, say, adjustable weights, like in our case, our machines have weights that slide on the side up and down. Swing the weights up into vertical neutral position and just start there, because you may not need extra down pressure. For coating removal, we do add down pressure in a lot of cases to be more aggressive to cut through that coating, especially on thick coatings. But start neutral and then add weight as needed. If you realize that you have a really soft concrete or substrate below, you may have to counterbalance weight, where you slide the weights all the way to the back and it actually pulls head pressure off. So you're not cutting too aggressive to the concrete below. So it all depends, and you just got to start with the neutral as far as weights go. RPMs, we typically say start on the kind of medium to lower side of things. As far as the SASE grinders, we have a potentiometer speed dial that goes from 0 to 10. And we typically start on coating removal somewhere around a speed 4 is a good starting point. And I always say, yeah, try it, push the limit, see how far you can go with it and still be productive. So go ahead and crank it up a little bit and a little bit of time, and then increase your walking pace when you increase your RPMs, and see what production you can get out of those tools on that particular floor. So, but once you see that there's a point of diminishing return, you've got to back it back down and find that happy medium where my walking pace is matching my RPMs, and this is the most effective and the fastest I can go, but still be effective. You kind of have to play with it, but a good starting point is speed 4. And then again, that's a range of 0 to 10 on our machine, and I believe it goes zeros around 300 or 400 RPM, and max is about 1300 RPM, just to give you some RPM range.
Okay.
The RPMs are a little bit different on our propane machines. You will have a digital readout that tells you what the RPMs are. It's giving you a shaft actually RPM, not the head, so it's not a direct correlation over. But a good starting point, if you're using a SASE propane grinder, is somewhere around, let's say, 26 to 2800 RPM is a good starting point for coating removal. And then from there, you can turn it up if you need to, and go on up to, say, 3000 if you need to RPM. So those are just some ranges to work with when you're starting off.
Yeah, and you should see some differences when you're doing that. I mean, you'll see that the faster you go, the more coating you're cutting up to a point. At some point, sometimes you'll see that it stops cutting, and that's because either you're heating it up too fast or you're just sliding across the top and not giving the coating time to tear.
Absolutely right. I think one of the best analogies is the boat and water. The faster the boat goes, the more it planes up and less the boat's in the water. The more you slow down, the more of the hull is in the water, and in this case, same thing with the diamond. So if you go slow enough, you may be cutting deeper and cutting more efficiently. If you spin too fast, you're planing up and you're skating on the top surface and barely scratching the surface. You're not removing as much. So there is a happy medium between those 2 points somewhere.
Okay.
All right, so this is the mastic slicers. These are basically just tungsten carbide. So these 3 pieces you see right here, and you see these are kind of removed just to give you an idea what they look like. It's just a tungsten carbide. There's a bolt that basically holds them down to this holder. In this scenario right here, they are designed to go in a counterclockwise direction. If you had a machine that needed to go clockwise, you could bolt them on this side and they would go clockwise. So they're basically, this tool can be used either direction, just bolt them on accordingly. These are awesome tools for really sticky gummy glues. And what's nice about this is because of the smooth surface that you see here that it leaves, it doesn't leave a rough profile at all. So you can follow this up easily with an 80 grit metal bond, sometimes even just a hybrid, like a 50 or 50 hybrid sometimes. Or if you're doing wet, you could go 100 hybrid behind it. So you're not even required sometimes to do a metal if you have a smooth surface below the glue. This is not leaving a profile. So that's kind of the beauty of this tool. You don't need to cut aggressive and don't need to cut deep, and you're just trying to cut glue or mastic off, I'd go to this tool because you're not going to have to deal with some deep scratches like the PCD type tools will leave behind.
Yeah, I think these are one of the most forgotten tools to use. You're talking about carpet glues, especially a brittle carpet glue is great.
Yep.
And you can just rip right through and be right into your hybrids, like you said, especially running wet. But But yeah, this is a tool that people are reluctant to get because you got about the holder and the blades, and you got to get it all in there and get it set. But each one has 4 sides, and it's got that similar bevel that you were talking about with the arrows. But yeah, this is one that just people fail to try. Now they're not friends of bolts and screws and stuff in this lab, but as far as from removing glue, I mean, this is carpet glue. If you run into carpet glue, this is, gosh, it should be the first thing you should try.
It is. It's awesome tool, especially if, let's say, maybe the spec calls for they want a Class A or even a Class B finish. They don't want to see aggregate. This is a good go-to because you're not going to cut deep below it, and you can start with a higher grit after this and not expose aggregate if that's what the customer doesn't want to do. For example,
we've used these on glue before. Have you run into people using them? Like if you get to a job that has thick cure and seal, would it be effective on that as well, or stick more with your metals?
It is. It won't remove all of it. It will remove a bulk of it, I guess, quite a bit of it. So again, let's say you have a thick cure and seal, and again, the spec is customer says I want a Class A exposure like a salt and pepper. They don't want to see aggregate. This would be a good option to run over it first, or chemically strip the cure and seal, and then that way you don't have to cut with a real aggressive metal bond to cut the rest of it off. You could go with something a much lighter, higher bond, and remove the remainder, then film this left behind, and then give your customer that salt and pepper or cream finish that they wanted in the first place.
Yeah, and I would say for the most part, they just will not cut into concrete. And so, we went into places where the cure and seal has been put down very poorly. This is a great way to kind of get the floor to an even starting point, because, we can go over a wave of cure and seal with a hybrid or a metal, and you're going to cut concrete on one side and you're going to be cutting coating on the other. Yes, eventually you get it all gone, but you got an uneven cut. This is a great way to kind of just get you an even starting place so that you're flat, relatively flat. Knock those waves down to kind of make your next cut look better too.
Absolutely right. Yeah, and just to point this out, a couple of things. I think you kind of pointed this out, Chad, but there are 4 separate sides, so you'll unbolt those and you can clock and rotate these a quarter turn each time to get the full life out of them. One of the things that we've seen people do, is very effective, is just remove the middle one, leave it out. Only bolt the top one and the bottom one in. And what we found that does is, especially like really thick gummy glues, it gives it sort of an evacuation pore, somewhere for it to get out and around. Otherwise, it gets clogged and stuck right here in the very beginning. I see this a lot on the really thick glues. So just leave this one out and run the 2 outer ones. And we found that they kind of self-clean a little bit better than when it's one big, full cutting edge like this. So that actually helps quite a bit.
That's a great point.
All right. So I talked about, pliable materials, mastics, glues, cut back, thing like that, black mastics, a failing epoxy. So if you've got just where maybe there's epoxy or some kind of a rigid coating that just didn't get a good bond or someone didn't prep correctly, we've found these will pop right up under it and just pop it off quick and easy and not damage the concrete below it. So this is another option for that scenario when you have a failing coating or a coating that didn't bond very well. So right on tile scrapers, you're probably using this in the first place if you're removing or demoing out, say, the VCT, vinyl composite tile, if you're cutting carpet out, quarry tile, whatever. But in a glue scenario for glue removal, we typically recommend customers, after they're done removing the VCT or carpet, flip the blade over or get a fresh blade and run quickly back over the whole floor and remove a ton of that residual glue. And a lot of times it saves you on having to spend time on cutting and doing glue removal. So you can go straight to like an 80 grit metal bond sometimes if you make a second pass with a sharp blade using your scraper to cut the glue off with. That's kind of a cool trick that we've seen guys doing.
And it does make a difference. Like you said, it's kind of like the carbide scrapers in that it just moves a bulk of the material out of the way first.
Absolutely right.
But it is heavily dependent on a sharp, blade. Yeah,
you got to have a sharp blade, and a lot of guys will just move to a sharp blade and maybe flip it over to get kind of double the life out of it sometimes, because you will dull it just trying to remove the glue. All right, so this next tool is kind of a new addition to our Wulf series, and I failed to mention at the beginning that the Wulf series is basically all of our SASE coating removal tools. So we kind of used the Wulf name and called it the Wulf Claw. This was developed for, specifically, actually, the story behind it was for the Walmart account. So basically, they were going in, they were popping up VCT. They have an evening, basically. They're working at night. and they'll do a couple aisles, I guess, a night. Let's call it 1,500 to maybe max 3,000 square feet a night. The goal is to pop up the VCT, remove the existing glue as we talked about, and then polish on up from there. And they have to get those sections completed and done and open before morning for a certain set time when customers start coming back into the store. We had a customer that basically was running into a situation where they had bid on some of these and they didn't actually realize that they were using epoxy mitigation, I guess, that was under the glue. He didn't realize it was there, so he wasn't accounting for that. And what it took, he was able, normally his normal system, he could pop the glue up, cut with 40 metals, remove the excess glue, 80 metals on up through his polishing system. Well, in this case, he was having to go down to 25 metal or PCDs to cut off that epoxy mitigation below the actual glue, and it was adding quite a bit of cost to it. So he asked us, "Hey, can you help out with whatever?" Well, so we started playing around with tools, and we actually developed this, the Wulf Claw. And what it is it's the magic behind it is not only just the shape and aggressiveness of the shape, but it's also the fact that it's a blend of grits. So this is a blend of basically like a 30-40 grit metal bond and a 60-80 grit blend. And what we're able to do was to remove that epoxy that's below the carpet glue and the carpet glue and one up and back pass. And then we could jump from there to our 100 C-bond hybrid. So we cut out not only one, but maybe possibly two metal bond steps in the process because of this. So since then, again, all this development was done wet at the time because the Walmarts were being done wet. Since that time, these tools have been out for almost about a year now. And we've got a lot of good feedback from guys that are dry grinding guys. And they say, well, yeah, I can do the same thing. I can run either of these Wulf Claws dry and then jump to your dry 100 hybrid. I will throw some caution to the wind, though. We have found on really, really hard concrete, you do have to run an 80 grit metal bond between this Wulf Claw before you go to your 100 hybrid. And you have an option, but if you don't want to run 80 metal, you could run a 50 hybrid, then 100 hybrid. But wet consistently, Wulf Claw, 100 C-bond wet, and then continue honing and polishing from there. Really awesome.
What you're showing here is a gold and a black version. That's your different bonds?
That's correct. Yeah. So as we talked in the last podcast, we talked about we have 6 different bonds that go from yellow as the softest bond, and then we have our orange is the hardest bond, depending on the concrete. So currently we only carry it in these 2 bonds. This is the gold for kind of your harder concrete, and then the black for your medium to softer concrete. We didn't realize how popular these have become. These have literally taken off. I mean, we can, for the last probably 4 months, it's very difficult to keep these on the shelf. It's very difficult to keep up with the demand, the popularity of these. So saying that, we anticipate expanding this line and make it its own line, the whole Wulf Claw line, with different bonds and maybe even different grits and things and blends. So it's really taken off. It's been super successful for us. So you'll probably see this expanding as time goes on.
Great.
So one last thing, guys are using it for not just that purpose, but they're using for glue removal, epoxy removal, just different things within reason, of course. Maybe 20 mils or less is pretty effective. So just a really awesome all-around tool. Getting into more aggressive than, let's say, past getting more aggressive than PCD tools, bush hammer tools. So these have been around for quite a long time. It's basically a rotary style tool that basically has, these are tungsten carbide, these little teeth are tungsten carbide, and you have them for the small machines like your 20-inch and smaller, like our 5K and 6K, then the bigger ones for your 8,000 machines or your bigger 32 an inch and larger. The point of these originally was to profile a surface, not for coating removal, not for anything else, but for profiling. They're used in Europe quite a bit when you had outdoor areas where maybe there were fountains or there could be a potential of a slip fall. So they would profile the surfaces and areas around there where it would be wet constantly, where it's a public area or a common area where people might slip or fall. Since then, it's been used for other things, for coating removal. We're giving specific surface prep for different types of coatings. For example, you can see on the screen I have up here, it's the bush hammer tools under a planetary grinder can achieve about a CSP of 5 to 7 based off of iCry's surface profile scale. So I just pulled this off of their website. So International Concrete Repair Institute, this is their profiles, and this is kind of their recommendation. So you've got like sealers based off of the mill thickness, thin mill, thin films, high build, self levelers, goes on up from there. And obviously all this information is going to be on, if you're looking at a certain coating, you go to their tech data sheets, they're going to recommend what CSP they actually want you to put this profile before their coating goes down in order for them to warranty it. And basically diamond grinding with a planetary grinder can give you, depending on the grit, from 1 up to probably 3. And then past that point, then you can get into like the 4 to 6 with the bush hammer tools. That's a pretty broad range with just a diamond grinder, a walk behind diamond grinder, from 1 to 6, depending on the tooling you have.
Shot blasting as a reference is probably picking you up somewhere around, I mean, it could be 1 with a brush blast, I guess. Gosh, you could almost get that with a power washer.
Yeah,
and then 2 and 3s, you're certainly getting that with a shot blaster.
Oh yeah, for sure. And heavy shot blast and heavy scarifying is going to be up in the top here when you start getting 8, 9, 10, all of that. So when would I use, like, let's say bush hammer tools? This is kind of, I love this picture because a customer sent this to me one time and said, "Hey, you're gonna love this, Clif." GC said, "Hey, I'm ready for you." And this is the picture that, he sent me. He walks out and this is what he's up against. The customer wasn't asking for large aggregate. They just wanted a nice salt and pepper. And this is the floor he's about to deal with. So obviously this floor needs a lot of help. We've got some repair obviously in the middle. At the end of the day, this whole floor ended up needing a polishable overlay put over it. The customer was going to be happy with what they wanted. So the whole floor needed to be overlaid with a polishable overlay. But in order to prep for that, they were able to remove that. They used the plate style PCDs to remove all of the membrane they had down below that. They had to do some patching first, and then of course overlay the entire floor. But there are some other scenarios where you would actually need the bush hammers. In this case, this would be like a failing cap. So there's different scenarios where you could have a failing cap, where maybe the bleed water gets trapped under the surface, where maybe the finisher got in a hurry and jumped on it too early and trapped the bleed water. Or maybe during the placement, there was high heat and wind blowing across the surface and create that barrier where you actually have the water trapped under the cap. But what happens, long story short, is basically the cap pops off and you get that 16th to 8th of an inch it pops off. If you have a major issue with a failing cap, a bush hammer is a perfect way to go over this whole floor, knock all that failing cap off, get it down to one level surface, and then you can make that determination if do we want to polish large aggregate at this point, or do we want to do an overlay if the customer doesn't want aggregate. So that's just another good scenario where bush hammers are very useful, and for profiling as well.
And can you use a bush hammer as a starting point if you're going for a large aggregate polish?
Absolutely. Yep. That was actually kind of one of the next slides I think I have in here talking about when you getting into large ag exposure.
Yeah.
Good segue in. So yeah, bush hammers, they're great. It's a great way to get to large aggregate. It's very fast and effective. They're very damaging though. I have to point that out. So that you got to think about the fact that the impact that they have on the surface. So you get a lot of microfracturing, you get a lot of chipping, you get a lot of pull outs and pop outs. So you got to be aware of that. If that's going to be an issue, sometimes just going really aggressive with a low metal bond is going to be a better option for you. It will take longer. So think of that as far as labor and time. But you do need to keep that in consideration. Sometimes a shaver or a scarifier is a better option.
And being a bush hammer isn't a great life. I mean, those things take a beating. They're the bearings. We've tried different brands of them and those kind of things, but it's a tool that delivers a great finish, but it's also a tool that, it takes a lot of beating. And so we do run into a lot of bearing issues and stuff like that. And we've seen different versions. But I hadn't seen the version that you just showed where it has the screw in bolt there. It looks like that's a little bit more rugged than what we've done before with like an axle type of version.
Yeah. This is our latest version, and it is better. Obviously, it's the wear part is obviously the tungsten carbide, and it's attached to that axle shaft that's there, and it's running inside a bearing housing inside of this. The back cap right there is removed, so you can actually access and service it to remove it, and then you reuse the plate and the housing. Again, you're not wrong though. These can be expensive. It can be a very expensive venture, but then again, it just depends on what the customer needs. If they have, let's say a floor looks like this, or a floor has a failing cap, that doesn't fall on the polisher. He didn't place them, unless he did, but not most cases. He didn't place and finish it. It should fall back on the finisher, or Mother Nature worked against them, and they just have to work with that. One of the things I do like pointing out is when we do get to large ag exposure, let's say this is what you're going to use, even if you're cutting with like low grit metal bonds, but especially bush hammers or shavers or scarifiers, you definitely want to do like a grout coat. always want to put that in as like a separate line item, because you're going to get pullouts, pop outs, fractures. It's just the nature of the beast. I mean, the deeper you get into concrete, the more entrained and entrapped air you actually expose. So it's just kind of a mandatory. If you're doing large ag exposure, a Class C, a CPC Class C, you want to make sure you always put in as a separate line item grout coat. It's just
Yeah, and it's never in the specification, but it's something that we try to make sure we always do as an alt an alt ad, because if you include it and you don't tell people you're including it, your price is going to be quite a bit high. And if you don't include it, they're going to assume that they're going to want to know why you didn't include it, and then expect you to handle it in your price. But it's quite the process, and there's several different ways to grout as well, depending on what you're running into.
Absolutely, it really is just different materials. There's different ways. I mean, there's some like, for example, the one that we sell. We're always full disclosure. We're an equipment and tooling manufacturer. All of our repair products like this are made by High Tech, private label for us, and then all of our chemicals, when it comes to dyes and intensifiers and sealers, it's all Ameripolish. So we're always full disclosure about that. But in this case, these are urethane-based products for the Allspal 3. If you're grinding and cutting wet, obviously urethane doesn't like moisture, so that's a problem. So there's other options, like Ameripolish makes their PG7K, I think it is, a grout coat that is more of a cementitious base. And it actually, you need to pre-wet the slab before you put it down anyway, kind of break that surface tension, allow it to get in as well. And it's kind of more like a primer binder for it. So depending on your application, if you're doing wet, you don't have time to let it dry out, then maybe something like that, the PG7K is an option. If you're dry grinding, the urethane is actually a better option. It's faster, it's actually harder, a little bit easier to work with too. So there are options depending on if you're a wet or dry grinding application for grout coat.
Yeah, and things to consider too when you're staining, because they stain differently. So you definitely want to make sure you're prepared for that as well.
Yeah, good point. I mean, you're right. The cementitious based product that I was referring to, Ameripolish makes, it will accept dye because it does have a cement paste product to it. Whereas the urethanes like this, they're an amber color naturally, and you'll put a tint pack in it. So depending on the tint pack you put in is what the color you're going to get in those pinholes and pores. We typically recommend to always go with a much lighter gray color, because I'd rather it look like a light speck of sand or a lighter aggregate in the floor, rather than if you go too dark and then you get we call a ghosting line, where you squeegee it out and maybe you didn't grind all the way through that, and you'll actually see. So a couple of things when you're grouting with a tinted grout. You want to go wall to wall, edge to edge. If you don't, you will see a line where you stopped and didn't actually get over with the grout coat. It will be visible later. So make sure you be aware of that. Go as thorough as you can go across the floor. Stop at control joints if you have to have a stopping point, because you will see where you start and stop, especially for tinted grout. And if you want to avoid all that, just go with the lightest gray color possible, and you're less likely to see a start and stop point when you're grouting with urethane tint based grouts.
Absolutely. No, and sometimes that color variation doesn't show up until you get to the high grits. And then that's a very discouraging thing to see.
It is, because there's only one way to cut it back out.
You just got to cut back down.
You got to cut it out with aggressive. Yeah.
Yep,
Yeah. That's pretty much everything I had in my slides there.
That's awesome, man. When you're talking about those things, how much wear and tear are you putting on your machines and those kind of things? Like, do you need to be prepared and for service? I mean, more flex couplers and belts and gears, those kinds of things. These are kinds of it's a different animal when you get into this market.
Absolutely, no, you're right. It's and that's something you should factor in when you're kind of bidding on jobs like that. It is more wear and tear on your equipment. I mean, I don't have a good number to give you. Like, does it cut a quarter to a quarter to an eighth of an inch less of the life, or a quarter eighth life left than what you normally get with just say grind and polish? Yeah, it probably does. Your belts, your drive system, whatever is driving your drums, your heads of your machine, like you said, your more flex couplers, or we have spring heads, whatever it may be, that is going to get more wear. Some companies like SASE and some others I know, they actually have heavy duty heads where you can replace with heavy duty springs for coating removal. And what some guys will do is they'll have fully assembled heads, that this is my coating removal head, and then this is my polishing head. And what that allows them to do is to stop breaking some of those engineered breakpoints so easily when they're doing coating removal with PCDs or say bush hammering. And they'll basically dedicate those heads for the heavy removal type stuff. and then have their more flexible heads with the softer springs, if you will, for polishing and just basic grinding.
Because when you're doing this kind of work, you want to have a rigid head. You don't want to follow the floor per se, like you do when you're polishing. You want a rigid head that'll really put the pressure on the elevated coating that you're trying to cut.
Yeah, that's correct. Yeah, that's exactly right.
Yeah, so Clif, that helps out a lot. So if you go back and look at this area, what are the 3 tools I should have on my truck at all times? Because I'm going to run into these things, and more times than not, you show up to find out that you have them. So what of the ones that we looked at, what are the 3 where you would say this should be in my bag of tools, every time?
Yep. I would say, going back to the fact that we have 6 different bonds of the basic metal bonds, I would say that carry at least 3 different bonds, and typically it's not going to be, say, our yellow. That's like our softest. That's kind of a rare situation. So you probably should have some lower grits in the gold. Really the blue and red are pretty popular in the black. So pick 3 of those depending on your region. If it's softer on the harder side, pick 3 of those bonds and carry like a 25, 40, and 80 in those. And then I would have the mastic slicers we talked about for the glue. Those are awesome. And then even just one set of PCD would be something to have. Like I talked about, they have the 2 quarter rounds in it. That's kind of a generic PCD that works in most cases. I'd have that on my truck as well. All the other stuff is really kind of specialty. Call us when you're having issues or when something else isn't working properly. We can get those to you pretty quick, and that would be something you want to order on a specialty case-by-case basis.
Well, there you go. That sounds good. Like I said, I think the PCDs thing, the PCD and the scrapers are the ones that trying to figure out which one to have, because if you use that full round, like I said, that can tear up some concrete. But there are times when that quarter or even the 8ths are great to kind of get through something thin, and they don't. The surface of the concrete, they'll slide over those a little bit more.
Yeah.
But the scrapers for sure. So. No, I agree with you. I think those are a great set of tools to kind of have in your arsenal when you head out.
Absolutely.
Well, man, this has been super helpful. I appreciate you coming on again and giving it. Definitely the visuals will help. So if you're listening to the podcast, certainly you can pull it up on a laptop or something and see what Clif is talking about. I think that'll kind of help a little bit. The arrows, seeing that bevel in there. I think a lot of the guys think that the point is what's doing it, but it's the bevel and the point that are working together. So, some good points in there, man. I really appreciate it, and thank you for coming on again.
Absolutely. Thanks for having me, Chad.
No problem. We'll talk to you again soon, I'm sure.
Yeah, that's great.
Thanks.
Thank you.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.